Hey, math lovers! Welcome back to Maths with Sass, where we make math simple and fun. Today, we're solving a fascinating geometry problem, finding the height h using just two given heights, p and q. We'll go step by step, define our variables, apply trigonometry, and finally, discover an interesting theorem known as the Cross Ladder Theorem. So grab a pen and paper, and let's dive in. Here's the problem. We have two vertical bars, one with height p and the other with height q. A line is drawn from the top of one bar to the base of the other, and vice versa. These two crossing lines intersect at height h. Our goal is to find h using only p and q. Let's define the key points. Point A and point C are the bases of the bars. Point B and point D are the tops of the bars. The two crossing lines meet at point E. The horizontal distances are labeled as x and y. The vertical height, where the lines intersect, is labeled as h. We also define two important angles. Alpha, which is the angle in the left triangle. Beta, which is the angle in the right triangle. Now, let's apply trigonometry to solve for h. First, let's take the left triangle, which contains alpha. Using basic trigonometry, we apply the tangent function. Tangent of alpha equals opposite over adjacent. So we write tangent alpha equals h divided by x. But from the full triangle, we also know tangent alpha equals q divided by x plus y. Since both expressions equal tangent alpha, we set them equal to each other. H divided by x equals q divided by x plus y. Let's hold on to this equation for now. Now, let's do the same for the right triangle, which contains beta. Using the tangent function, we write tangent of beta equals opposite over adjacent. So, tangent beta equals h divided by y. From the full triangle, we also know tangent beta equals p divided by x plus y. Since both expressions equal tangent beta, we set them equal to each other. H divided by y equals p divided by x plus y. Now, we have two key equations. Now, let's solve for h. From the first equation, h divided by q equals x divided by x plus y. From the second equation, h divided by p equals y divided by x plus y. Now, let's add both sides together. H divided by p plus h divided by q equals x divided by x plus y plus y divided by x plus y. Since the denominator x plus y cancels out, we simplify to h divided by p plus h divided by q equals 1. Rearranging this equation, we solve for h. H equals p times q divided by p plus q. And that's our final formula. This formula is actually a special case of the Cross Ladder Theorem. This theorem states that the intersection height in a crisscrossing structure always follows the rule h equals p times q divided by p plus q. This is a beautiful mathematical result that shows how ratios and proportions naturally appear in geometry. If you found this lesson useful, hit that like button, subscribe, and turn on notifications so you never miss amazing math tricks. Thanks for watching, and I'll see you in the next video.